So here are the solutions to problem set 4, where we were sketching angles in standard position and then working with something called reference angles. Now I'm going to go over the last 4 problems in great detail, and then in the new lesson, make sure you view that as well. I'm going to do some more examples. All right, so as we were looking at angles that we were sketching in standard position, a negative or a positive angle simply means the direction of rotation. So when the rotation of an angle, or the rotation of an angle is its measure, the measure is positive if the rotation is counterclockwise. Because remember, if we're looking at counterclockwise, when we have this sketched, our initial side always goes on the positive side of the x-axis. So if we start to go up, meaning positive, we're actually going around this way. So this is a counterclockwise rotation. So the measure is positive if the rotation is counterclockwise, and then if the rotation is clockwise, the measure is going to be negative. So here we would have our initial side, and then we would start down or in a clockwise rotation for a negative angle measure. So again, negative just means the direction that we're leaving that initial side. All right, so for problems 2 through 9, all we have to do is sketch the angle in standard position, a rough estimate of where that terminal side is going to be, and then we indicate which quadrant or on which axis it ends up in. So 140 degrees. Now, I'm not going to draw this for all of them, but you guys definitely can. I'll just start with a couple. But remember, I always said that we could put the 90 degrees if we're looking at positive, 180 over to the left here, 270 at the bottom, and then 360 at the top. So remember, the zeros also starts where the 360 ends, but we don't always have to write both of them. All right, so we want 140 degrees, so we first draw on our initial side. And then 140 degrees is going to end up in quadrant 2. And again, we write in like the 90, the 180, 270, and so on, just to get a good idea of where this is going to go. So we're not just drawing it anywhere in the second quadrant, but relative to the 90 degrees and 180 degrees. So it is a little bit closer to the 180 degrees, so drawing maybe something like this. And then indicating, if you didn't get, it's always good to indicate the direction of the rotation. So we're looking at it here. And again, we're letting like theta equal 140. So we could put theta there, or you could just label that 140 degrees. All right, now for 320, we're almost full circle here, so it's going to be pretty close to the 360. This is quadrant 4. So again, I have my initial side. So in between 270 and 360, I'm about 40 degrees away from 360. So again, I could draw my terminal side just right about there. And again, we could show the direction of the rotation, and we could label that as theta. All right, for 245, if I just go back to number 2, 245 is going to be in the third quadrant in between 180 and 270. So again, I'm going to draw my initial side and maybe making it a little bit closer to 270. So something like this, drawing in the direction here as such. Again, they're positive, so this counterclockwise rotation, and then this is quadrant 3. All right, for number 5, 70 degrees, we're in the first quadrant. We're between 0 and 90, a little bit closer to 90. So here's my initial side, terminal side right about up here. And again, showing that direction. Again, you could call it theta, or you could just put in the angle measure as well. All right, so now we get to number 6, where our angle is now negative. So I'm going to go ahead and write this in. That just means that down here we'll have the negative 90 degrees. Over to the left will be negative 180. Negative 270, and then negative 360, because we're going to rotate in a clockwise rotation here. So again, I draw my initial side. Negative 80 is just right before the negative 90, so we're going to end up being in quadrant 4. Just number 5, I forgot to state, that was quadrant 1. So quadrant 4 for number 6, and we're about 10 degrees shy of reaching that negative 90, so we can maybe make it like this, and then draw on our rotation arrow and our theta symbol. Negative 205 the same way. Here we have our initial side. Negative 205 is going to be between negative 180 and negative 270, just a little bit past the negative 180, so like 25 degrees is what we're looking at, so maybe something that looks like this. But again, we want to show that we rotated in a clockwise rotation here, and then we could label theta, so we are in quadrant 2 for that one. Negative 298. Again, if I go back up to number 6, negative 298 is going to be up here in quadrant 1 between negative 270 and negative 360. Here's my initial side. So negative 298, we're looking at maybe it's just 28 degrees past the negative 270, so kind of showing it like this. But again, we want to show that rotation clockwise like this. And then number 9, negative 110 is going to be in quadrant 3 because we're just a little bit past the negative 90 here. So here's my initial side. I'm going to show 20 degrees past that. So we're looking at this, quadrant 3, and then the direction as such. All right, so hopefully you found these to be a little bit on the easier side. I know some of the examples I gave that we kind of like rotated a couple of times, but we didn't see that yet on here. I'm going to talk about that when we get into maybe numbers 20 to 23 and then in the new lesson as well. All right, now we switch to reference angles. Remember, reference angles is just asking how far from the x-axis are we, and it depends on which quadrant we're in to determine what we end up referring to, or referencing in this case. All right, so remember, a reference angle is always going to be an acute angle. It's always going to be less than 90 degrees. It's always going to be positive. And then the symbol is theta prime for the reference angle. Again, always acute and always positive. All right, so this helps if we first make a sketch of our angle. So 155 degrees, again, just as we did 2 through 9 here. Here's my initial side. 155 degrees puts me in quadrant 2. Remember the 4 cases I had in the lesson here. Pretty close to 180, so I could just draw it somewhat over here. So I'm referencing 180. So my theta prime is going to be this part right here. So this is theta prime. What I have drawn in so far, that's theta. So that 155, that's theta. So theta prime is going to be how much further do I need to go to get to 180? So that's just 180 minus 155, which will give me 25 degrees. So theta prime is equal to 25 degrees. So all I would need to do is just go 25 more degrees from that 155 from that terminal side. It only needs to sort of fall or rotate 25 more degrees in order to reach the 180. All right, so for 242, again, this is theta. Draw my initial side here, 242. Again, I'm just going back up to number 2 to show the angle markings here. 242 is going to be in the 3rd quadrant. My terminal side, that is. So I'm still basing this off of 180. So my terminal side, right about here. So again, this is theta. This part here, how much further than the 180 degrees did we go? This is theta prime. So theta prime in this case is going to be 242 minus 180, which will be 62. So my reference angle, I just went 62 degrees past the x-axis there, past 180 degrees. All right, for 325 is going to show up in the 4th quadrant, the terminal side, that is. Here's my initial side. So 325, we're looking at just 55 degrees past 270. So we could draw this right about here. All right, so again, this is theta. Drawing this in, this is theta. So my reference angle is this little part right here. How much further do I need to go to get back to 360? So theta prime is going to equal 360 minus 325, which will just give me 35 degrees. That's my reference angle. So notice all these reference angles are acute, meaning they're less than 90, and they're positive, because again, we're kind of looking at distance here, but distance measured as a degree. All right, so let's take a look at the others. All right, so theta for number 13 is 37 degrees. That puts us in quadrant 1. So looking at 37 degrees here. So if I have theta drawn in, my reference angle is still going to be the same. Remember, in quadrant 1, theta prime is equal to theta. So theta prime is also 37 degrees because it's just saying we are 37 degrees above the x-axis, measuring from 0 in this case. All right, now we're going to switch to some negative angle measures. So again, this is just showing us how we draw this in. All right, so negative 28, remember, means I'm just rotating in a clockwise rotation here. So I'm just 28 degrees below the x-axis. So we can look at it this way. So there's theta, which means theta prime, the way that this is drawn, would also have the same measurement but be positive. So theta prime, in this case, we could say just 360 minus the 28 that we're looking at here. So theta prime is just going to equal 28 degrees. And when I said that, I'm thinking like if we did 360 minus 28, we could find this positive angle measure. So if we were looking at 360 minus 28, so again, there's a couple ways to look at this. All we really need to know is the difference between 212 and 180. We're just going in an opposite direction here. So 212 minus 180 is going to give us just 32 degrees. So theta prime is going to equal 32 degrees. If you wanted to determine the coterminal angle, what would be the positive measure? All you'd have to do is 360 minus 212, and we're going to get 148. And then you could also do that theta prime is equal to 180 minus 148 that way. So it's a lot easier if we're looking at a theta measure that is positive. So again, this is what I mean when I say you can figure out the coterminal angle and just figure out the difference between the angle measure we're given and 360. But this would also give us 32 degrees. All right, looking at 16, negative 126 degrees. So that's going to put us in quadrant 3. Negative 126, just 36 degrees past the 90 mark here. So we could look at something like this. So again, this would be theta. Again, we're basing this off of 180. We just need to figure out how much further we need to go here for theta prime. So again, we could just do the 180 minus a 26 because in all reality, we've just rotated 126 degrees. We need to figure out how much more we need to go to get to 180. So theta prime is going to equal 180 minus 126, or you could go figure out the coterminal angle, positive angle measure, and just subtract 180 from that. So a couple different ways to do this. All right, so we're actually going to get 54 degrees, so theta prime, our reference angle is 54 degrees. All right, now these last few, or 17 and 18, this is going to show us going around more than once. So if we're looking at theta is equal to 390 degrees, remember 360 degrees makes a circle, so we're going one full circle and then 30 degrees more. So here's my initial side. I'm going to rotate one full rotation and then about 30 degrees more, so right about here. So all I really need to know is what's in purple, that's theta. So I went one full circle and then a little bit over, but my reference angle is just still this little bit right here. How much further past the x-axis did we go? So this is theta prime, and that's just 36 degrees. So 390 minus 360 is 30 degrees, and that's less than 90. If I went a little bit further, I would have to reference another degree measure here. So that means theta prime, because we're in quadrant 1, is also going to be 30 degrees. Now the drawings, they help, they're not necessary, but they help just to get a good visual of how much more we have to rotate in order to get our answer. All right, so now for 700 degrees. Now keep in mind, we're definitely over 360, and just know 360 times 2 is 720, so we're not quite at 2 full rotations. So just to draw this in. Here's our initial side. We're going to go one full rotation. There's 360, and I'm just going to be 20 degrees shy of a full second rotation. So I'm going to go around again and maybe end up right here. So my terminal side is going to look like this. So because I'm 20 degrees short of 2 full rotations, that 20 degrees is my reference angle. So What I have here in green, that's theta. What is here in blue is our reference angle theta prime. So sometimes the picture helps and we don't have to remember, do we subtract from 360? Do we subtract from 180? We could just look at the picture and help us determine how much further we needed to go. So that's 20 degrees. All right, and back to a positive angle measure here for number 19, 195 degrees. So we're just 15 degrees past 180, and that's a good way to reference it. So I know I'm basing this off of 180 degrees. I'm just going to be 15 degrees past it. So here is theta, which means this little bit right here, which is the 15 degrees. That's theta prime. So theta prime in this case would be the 195 minus 180, which will give me 15 degrees. All right, now for these last four, I wanted you to sort of think critically about these and see if you could figure these out. If not, please follow along now, as these would kind of be notes for the upcoming lesson. All right, so here we're given, we have to work backwards, and we can have more than one correct answer here. Given that theta prime means the reference angle, find theta, the angle of which theta prime is a reference angle for. All right, so we have to be told which quadrant we're in. So we're going to be working in quadrant 3, where our terminal side ends up. And then theta prime is 10 degrees. So that, remember, this means from the x-axis. So if I'm in the third quadrant, I'm 10 degrees past this x-axis right here. So here's my initial side. So I could draw theta like this. So in this case, theta is going to equal 180 plus 10, which will give me 190 degrees. That's one answer for this. I could also figure out a negative angle measure. So this could also be theta. Now this means I'm 10 degrees because I'm going in the opposite direction. I'm 10 degrees shy of 180. So we could say, or theta could equal just being shy of 180 degrees, but negative would be negative 170. Or we could be even more clever, but it's a lot more work. We could go around one full circle. So just to draw this in, I could show that I can go around one full circle. So there's 360 plus another 190. So that could give me, I could show that I could add that 190 and then go another full circle here. Or we could go around 2 full circles or 3 full circles. It never ends. There's an infinite number of angle measurements that will still end us up with the same terminal side in quadrant 3. So we could say that this would be 550. But this first one is the simplest to get to. All right, so maybe just pause the video, try the next one. So here theta prime is 70 degrees. We're in quadrant 2, so we're over here. Now this means, again, we're 75 degrees before 180. So if I were to draw my initial side here, I'm 75 degrees past it, or before it, so I'm going to have my terminal side up here. Because remember, it's this part that's theta prime. That has to be the 75 degrees. So now to figure out what theta is going to be, again, the simplest one, making it just a positive angle measure. Theta would give me 105 degrees. Again, we could go around and make a negative angle measure if you wish. You could go around one full circle and then add, that would be another 105 to that. All right, go ahead and also pause the video again. Try 22. Here we're in quadrant 4 and theta prime is 20 degrees. So quadrant 4 is down here, again drawing in our initial side. So we're just 20 degrees before the x-axis. So that means if we're in quadrant 4, our terminal side shows up right here. This part is the 20 degrees. That's theta prime. So again, the easiest answer to get to, keeping it positive, is to go around this way. So if we're just 20 degrees shy of 360, that means our theta, or angle, could just measure 340 degrees. Or, in this case, pretty simple, we could just go in a clockwise rotation and say that theta could equal a negative 20 degrees because we're just rotating down from that initial side in a clockwise rotation. So both of those are very easy answers to get to. And then our last one, go ahead and pause again, sketch the initial side and determine where that terminal side is going to be. We are in quadrant 1. So theta prime is equal to 25. Now this one maybe doesn't even require a sketch, but we have our initial side. If we're in quadrant 1 and theta prime is 25 degrees, that just means we're 25 degrees above the x-axis. So this is theta prime. It's also theta. One easy answer to say here is we're in the first quadrant. Remember, theta prime is equal to theta. So theta is also equal to 25 degrees. So like I said, we'll practice a few more in our new lesson, but let me know after going over this if you guys have any questions.